We'll now explore the DTFT of a not periodic signal. The sequence that we are interested in is this sequence. In fact, it is almost the same sequence as before. From 0 to 7, it looks the same. However, the difference is in this sequence, the 0 extends to infinity. So it's zeros all the way to infinity, and from -1 to infinity is also all 0. However, the first 4 values are the same as the previous example if you look carefully. Okay, over here. Now, so what gives? Well, since this is an aperiodic signal, then we can only use the DTFT equation to perform analysis. X of omega is equals to this equation over here. And of course, trying to sum anything to infinity might be that might not converge, but fortunately for us, the support means the non-zero values are only from 0 to 3. Alright, so what we really do is that instead of summing from minus infinity to infinity, we're actually summing only from 0 to 3 over here. 0, 1, 2, 3. There are non-zeros, and these are value of 1. And then we can substitute e minus j omega n, and of course n will go from 0 to 3 only. And what about omega? Now omega actually goes from minus infinity to infinity, but in real cases we only need to go from 0 to 2 pi or from minus pi to pi. We're going to choose from 0 to 2 pi, and the reason is that you realize later on that x of omega is 2 pi periodic, so we only need to calculate one period of 2 pi. 0 to 2 pi is the typical one that we're going to calculate. Anyway, so what we do is we calculate from 0, this is omega over here. So this is omega, we're going to calculate 0, this is 1 times pi, 2 times pi, okay, so this horizontal. Then we can also calculate from 0 to minus pi minus 2 pi. Alright, so what we do is that we see that actually this is 2 pi periodic, meaning from pi to 0, it looks like this shape, and from 0 to 2 pi, it looks like this shape. So it is 2 pi periodic. Alright, so how do we get all these little points in between? What we do is that we really substitute different values of omega that we want. So we can start with 0, 0 0.1, 0 0.2, 0, 0 0.1 pi, 0 0.2 pi until 2 pi. So we substitute here, we put it into this equation and do this for loop. So you can actually see the values over here. Okay, so how do I do it? This is my MATLAB code to do it. What I did was simply I have the for loop of the horizontal axis from minus 2 pi to pi, and then I actually just write this summation, and this summation, if you see it very carefully, it is nothing but summation of n equals to 0 to n equals to 3 for x of n e minus j omega n. So this is n equals to 0, this is n equals to 1, n equals to 2, n equals to 3. The capital W is the omega, and we are summing for this only this 4 term, and we are calculating for the different x omega at different case. Okay, as in the case will be ranging from minus 2 pi to 2 pi. Alright, so in this figure, you will see my implementation of the DTFT of a aperiodic sequence. Although it has sum to minus infinity to infinity, it has finite support, and we can therefore write this little equation to represent this sum, and this is the output. Thank you.